Let me show you how to be a good Bayesian.
Today, we are doing something a little different. A proper philosophy of science episode. And one of my favorite conversations in a while. My guest is Vaden Masrani, a machine learning researcher turned consultant and the co-host of the Increments podcast with Ben Chuck. Andreas Munk from episode 155 put us in touch, and I am so glad he did. Vaden has a sharp, unusual position. He loves Bayesian statistics, and he's deeply critical of Bayesian epistemology. So we spend the episode walking that line. Why is it wonderful to use Bayes' theorem when you have data and a model you can falsify? And why does it go wrong the moment you start assigning probability to one-off future events with nothing to count? From there, we get into the problem of induction, Karl Popper and critical rationalism, why criticism rather than falsifiability sits at the foundation of knowledge, and how all of this shows up in stand-up comedy, Stoicism, and even the downfall of Sam Bankman-Fried. It is playful, contrarian, and it made me think a lot. I had more questions, actually, than we had time for, so I am going on Vaden's show to keep the conversation going. Stay tuned for that. This is Learning Bayesian Statistics, episode 160, recorded May 20, 2026.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence.
Welcome to Learning Bayesian Statistics, a podcast about Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the show, learnbayesstats.com is la place to be. Show notes, becoming a corporate sponsor, unlocking Bayesian merch, supporting the show on Patreon, everything is in there. That's learnbayesstats.com. If you're interested in one-on-one mentorship, online courses, or statistical consulting, feel free to reach out and book a call at topmate.io/Alex_Andorra. See you around, folks, and best Bayesian wishes to you all. Vaden Masrani, welcome to Learning Bayesian Statistics.
Nice to be here.
Yes, I'm very happy to have you on the show. You were recommended to me by Andreas Munk from episode 155. So of course, Andreas's episode will be in the related episodes for that one. But that's how we met, and I'm very happy that we did, because I think we have a fun episode in front of us today. Before that, though, as usual, what is your origin story? What are you doing nowadays, and how did you end up doing that?
Yeah. So I know Andreas from grad school. We did our PhDs together at UBC in a probabilistic machine learning reading group, lab rather. And how I got there is kind of an interesting story. So my undergrad was in physics, and so near the end of my undergrad, I was working for the ATLAS experiment, which is the one that discovered the Higgs boson, in 2013. To be extremely clear, I had nothing to do with the discovery of the Higgs boson. I was just an undergrad making plots. But my my summer project was to train neural networks to detect a particular kind of particle decay. And through that process, I realized I was way more interested in the neural networks side of things than the particle decay side of things. So I kind of pivoted and then did my master's in ML at UBC as well, more on the applied side of the research. And then that led me to working in Tokyo in a Bayesian ML group there with Imtiaz Khan at RIKEN, doing variational inference kinds of work. And I just loved that experience so much that I decided as a masochist to do the whole PhD experience. And that was a lot of fun. So that kind of takes us to a couple years ago. So after that, I was doing some research at one of the big companies and didn't love industry research as much. So I jumped from that about 2 years ago, a year and a half ago, and started a consulting company. And that's kind of what I've been doing ever since. And so a lot of industry projects, not so much Bayesian statistics anymore, but lots on the philosophy side of things. I should probably also mention, so in the sometime during the PhD, maybe first year of COVID, I started a podcast with a friend of mine. And in that space, we talk a lot about Bayesian things, also the philosophy of science and history and all these various subjects. And so that's been just a extremely valuable source of intellectual nourishment because you don't have any of the publish or perish constraints. You can just freely explore ideas at your kind of following your interests, and so that's what I'm spending most of my time these days doing. Because consulting, kind of the 9 to 5, and then podcasting on the 5 to 9.
Yeah, we'll talk a bit more about your podcast. That's the Increments podcast with Ben Chug. So definitely, folks should check it out. But we'll talk about it in later in the show, and of course. You will have everything in the show notes. People, if you want to check out Vaden's podcast, I definitely encourage you to. And on YouTube also, well, you'll have that on his. This episode will also be on his YouTube channel, thanks to the magic of YouTube collaborations. So yeah, definitely check that out. On the consulting side, actually, so if I remember correctly, your company is called Sophia Consulting, right?
Mm-hmm. Sophia AI.
Yeah, Sophia AI Consulting. So 2 questions. What do you guys do? And also, is my guess right that the Sophia is in relationship to philosophy and coming from the Greek word for wisdom, or is that unrelated?
No, it's totally related. Nice catch. You're one of the few to catch that. Yeah. So yeah, Sophia means lover of wisdom. And I kind of liked introducing a nod to wisdom compared to, say, intelligence, which is a vastly overused word these days. And so, yeah, what we do is essentially just working with companies on their real world problems. And so maybe the easiest way is just to explain one of the projects we just concluded. So there's a local company called AquaEye, and they make an underwater sonar gun that detects drowning swimmers. And so you have a diver out at 5 meters, 10 meters, up to 50 meters, and you're bouncing sonar off of them. And then you do a lot of data cleaning, and then you train a fast CNN so that it works on device, essentially. And we just released the AquaEye Pro model, which has moved over from random forests to CNNs. And so that's been one of the major projects I've been working on for the last couple of years almost. That's kind of in the space of machine learning in AI. So I know that these terms are overloaded and mean many different things to different people, but I am these days using AI to refer to chatbots and anything that's generative, whereas ML is more the traditional make a prediction. So the AquaEye was one of the major ML projects we've been working on. On the AI side of things, I was working with another local company called Huge that's making a smart home assistant that lives on device entirely locally, so you can trust it with more personal data because none of that data would have to leave the box. So there's just kind of 2 of the projects that I work on, but in general, I just really love the real world problem solving component of consulting, which is very different than publishing papers, for instance. As I'm sure many of your listeners know, publishing papers is extremely important and difficult, but there's all sorts of problems that come online when you're dealing with a real data set that you've actually had to collect and actually have to clean up. And so those kinds of challenges have been just loads of fun to work on these days because you're actually able to save lives and make a positive impact on the world.
Wow. Okay. This is super cool. So, and I'm not gonna argue with you that podcasts are a great way to stay up to date with the research with a lot more freedom, and same for that kind of research that you just talked about. Definitely resonates with me. And also, I'm curious for Sophia AI, do you what are you always taking these kind of projects on, or is that something like that's Like, is that project representative of what you do, or do you usually do other kind of consulting? Yeah, I'm just curious how that works because I used to do professional statistical consulting, so I'm always curious about other people.
Yeah. So the word consulting can mean a lot of different things, from
Right.
charging $100,000 for a PowerPoint presentation to working in the weeds in programming. And then obviously there's like the strategic direction side of things if the company's newer. And so it kind of depends on the project. I like to think of myself as a bit of a jack of all trades, in the sense of having the research background to be able to determine what kind of projects are feasible compared to we want to train a bot to predict the stock market kinds of projects, which just aren't feasible. And so sometimes the projects are more at the high level of working with the founder and offering like strategic direction about, okay, if you want to do X, well, you're going to have to do A, B, and C first, and what's the risks associated with A, B, and C. If the company is a bit more advanced, if it's been around for a long time and they have a more concrete research problem, then often I'm the person that they reach to when they need to figure out exactly how to run the experiments, how to validate the models, how to make sure that you haven't accidentally overfit and given yourself extremely unrealistic positive results, which is something that's easy to make that kind of mistake when you're new to this. So it very much depends on the client and what their needs are. But one of the things I just love so much about, let's say, machine learning, data science, is that data gives you knowing how to work with data gives you an all-access hall pass into everyone else's industry. So I don't need to know much about how sonar works, but if I know enough about Fourier and signal stuff, then I can learn that. There's another company I was working for that was doing predictive analytics for heavy machinery in the Amazon rainforest. And so it was super cool to learn all about trucks and how trucks and stuff work. So I like the fact that each job is different. Each job requires really understanding the unique problem situation that the company is in and what their goals are, and then being able to offer some both strategic direction, but then also highly technical instructions to their team if they already have engineers, or doing the first round of POCs and prototypes to demonstrate that the idea is viable. So it totally ranges. I have yet to charge $100,000 for a PowerPoint presentation, but I'm hoping such opportunities will present themselves. But in general, it ranges from the actually doing it, programming POCs, all the way up to offering recommendations about which direction the company should pursue.
Okay. Well, basically the whole range you could do, but you of course do a lot of modeling because that's a lot of your background. Yeah. Okay. Interesting. And that makes sense also with my personal experience. Yeah, sounds like you guys are doing very, very interesting work. Well done.
Yeah, it's a lot of fun
on doing that. How many are you now in the company?
Just one, baby. So we there's another idea which it's a bit too early to discuss right now, but for that idea, I say we because I'm an academic at heart and I cringe saying I, but so there's an idea that I'm potentially pursuing VC funding for, and I'm going to go the more startup route. And if we go that direction, then definitely we'll be hiring and stuff. But right now I like being agile, versatile, and being able to pick up projects as they come. There's a bit of a difficulty when you want to scale in the consulting world because you need to have enough steady clients coming in that you can then guarantee steady work for the people you hire. And right now it's been just a lean kind of just me and my laptop and just a bunch of networking and stuff. But if we decide to do the VC route, then I'll be kind of going in more of the hiring direction.
Yeah, makes sense. So good luck with that, and hopefully you get what you want.
Yeah.
If we focus on the Bayesian side of things now, what drew you to Bayesian methods in the first place?
Yeah, so that's a good question. What drew me to Bayesian methods was partially just how beautiful the math was. So there's loads of applications in Bayesian statistics, as you and your audience are quite familiar with. But what I found personally exciting is just how deep the research opportunities are. And It's interesting because in industry, I've found that there have been less applications than I would have kind of guessed being in academia. But the applications in industry are very much like the fundamental scientific level. So protein discovery, or obviously diffusion models are a big one. And so I liked the coupling of pretty math with real world applications. And my master's was in a bit of a different domain. It was about predicting predicting the stage of a patient's Alzheimer's diagnosis based on speech analysis. And so very kind of just black and white ML problem. You get a bunch of text, you compute features, you do parse trees, and you count morphemes and all this, and then you train a classifier. And so that was a great experience to kind of get a good understanding of like the applications of ML. But through that experience, I didn't feel like I had a good understanding of how these algorithms actually worked. There's a major difference between pulling off, say, a logistic regression model from sklearn versus actually like deriving the updates and doing it on the whiteboard. And so the pivot into Bayesian stuff was largely motivated by liking the applications and liking the opportunity to really dive deep into how a lot of this stuff worked. And then that's what led to the PhD, and so that's kind of how I got into it.
Okay. So that was pretty early in your career, right? It was even before even working.
Yeah. So it was at the end of my master's. I took a late internship, and that was my opportunity to decide if I wanted to continue in the academia route or make the jump to industry. I actually did 2 back-to-back internships. One was at Samsung, and the other was at in Tokyo. Actually, opposite way around: Tokyo then Samsung. And those 2 back-to-back experiences definitively convinced me that I want to stay in academia land. I didn't like the working at a megacorp aspect so much. It's nice to have like well-funded coffee machines and lunch stations and stuff, but I much preferred like the difficult whiteboard sessions that the Tokyo experience offered. And so that kind of sealed the deal. And then I decided to do the PhD and then never looked back. Yeah.
Okay. Yeah. Very cool.
Yeah.
And actually something you distinguish a lot in your own work and podcast is distinguishing Bayesian statistics from Bayesian epistemology. So this is a very practical podcast. So sometimes we talk about it, like episode 50 with David Spiegelhalter, episode 51 with Aubrey Clayton. So we do mention philosophy and epistemology from time to time, but we are usually more a practitioners podcast. So I'm very interested to hear about you today, because can you, for listeners who haven't heard framed it that way before, can you tell us what the actual difference is between statistics and epistemology?
Yeah. So that's a big question. I'll just lay my cards and my biases out on the table, because I am extremely in favor of Bayesian statistics because of the myriad of applications that Bayesian stats has. Just in researching this episode, I was just like, ChatGPT, give me some just examples. So obviously SLAM and Kalman filters and VAEs is all well understood. MCMC, that's all well understood, but there is a nice example of, I guess, France Airline 447 went down about a couple decades ago, and Bayesian stats was used to be able to recover the wreckage. So huge amounts of applications. That's great. Bayesian epistemology, I'm extremely critical of, and I don't like it as an epistemology. I obviously haven't defined it yet, but that's kind of the position I'm coming from. And so I'm going to give you an opinionated take on what Bayesian statistics or Bayesian epistemology is, and then we should probably talk about epistemology in general, because I think Bayesian epistemology is best understood contrasted against another epistemology. But so if I can take a bit of a roundabout way to get there, there's a podcast episode with Toby Ord and Sam Harris. And this podcast episode came out maybe 5 or 6 years ago. And in this episode, Ord was talking about his most recent book called The Precipice at the time. And he was talking about existential risks. And so he was talking about, so what's the probability that we will die from an asteroid? Or what's the probability that we'll die from a volcanic eruption? And so you can assign numbers to these because you have a data set to look at. So you can look at the number of supervolcanoes in the geological record over the last couple hundred millennia, and then you can start doing some basic take account, divide it by time to get probability associated with it. But then he switched and he started talking about what's the probability that we will all die from superintelligence in the next 100 years. And then he assigned a probability to that too. But if you are a statistician, if you're a Bayesian statistician, I think your first question should be, well, where are the statistics? What are we putting into these models? How can you come up with a probability of something that's going to happen in the future when there's nothing to count, right? And in particular, how is it a valid move to compare probabilities derived without data against probabilities that come from data? Because in this episode, Ord was essentially making the point that we have a 1 in, I believe in this book, it's 1 in 10 chance of extinction due to superintelligence. And he contrasted that against 1 in, I'm just going to make up a number, 1 in a billion chance of earthquake. So that got my little radar binging, my little bullshit detector binging, because if you have a model and you train that model on zero data, how is that a model? Where is the statistics? So the answer to your question, the kind of the tongue-in-cheek answer, is that Bayesian epistemology is Bayesian statistics minus the statistics. It's just the equations. How that actually works in practice and why some philosophers, particularly ones that come out of Oxford these days, why that they consider that to be a valid move, where all other statisticians, Bayesian or frequentist, would say, hold on, if you are drawing a scatter plot and you do a line of best fit on an empty whiteboard with no dots, you're just doing lines on a whiteboard, how is that a model? So the answer to your question, at a surface level, is that Bayesian epistemology is what happens when you take Bayes' theorem way too seriously and you forget about the data. And then you start coming up with numbers and you kind of convince yourself that these numbers are legitimate because you're calling them probabilities, when in fact they're made up. They're made up out of your head. And you then are making decisions based on made up numbers, which you've called a probability. Now, if there was someone who was a Bayesian epistemologist on this podcast, they would strongly disagree with my description of this. And so from their perspective, which we can maybe steel man in a bit here, they have a different story to tell. So I do want to be clear to the audience that I'm giving a biased accounting. And so maybe I'll pause there to let you kind of poke and prod at some of the stuff I said, but it is an interesting question. Why are some philosophy departments okay with using probabilistic estimates that don't come from any data? And the answer to that is due to 100 years of literature that can all be kind of considered to be Bayesian epistemology. Yeah.
Mm-hmm, mm-hmm. Okay. Yeah, thanks. That's a very clear explanation of the difference. I really find that interesting. So I spend most of my time thinking about statistics and models, and not so much about philosophy and epistemology. But so I do have a few questions. And I'll mainly try and rephrase what you told me to make sure I understood. So please let me know if I didn't. The main thing that bothers you about Bayesian epistemology is in the scenarios where you don't have data to update your beliefs. Is that correct?
I would frame that as that's the most immediate example of the problems with Bayesian epistemology.
Huh.
That's one that I think a listener can grok without having to talk about Cox's theorem, or why, for example, we conflate probability distribution with the psychological phenomenon of having beliefs in the first place. There's questions about why that connection even makes sense. So there's a lot of philosophical reasons why I don't think it's going to work. But I like to start with a clear example of how it can get us into trouble. And so I guess my comments there is that's just the tip of the iceberg, but that's one reason, because I think it can trick people into making decisions that are poorly informed because they're using a lot of math, and using a lot of math is not sufficient to making a good decision. But Bayes' theorem, divorced from the data, when it's just Bayes' theorem, that I think can be quite enticing to people, and it can lead them astray. So that would be how.
Yes, so I do fully agree with the dangers of basically math washing, and it's used a lot in politics and basically like people who want to convince you of something they think is true, and then they just try to just shoe in what they already believe into a math package to give it the illusion of objectivity. I'm less disturbed by by the fact of using Bayes' theorem without data, because so one thing I thought I understood, but I may be completely wrong on that, is in the Bayesian epistemology framework, you define probability not as a long-term frequency, but as a degree of belief. So if you accept that definition of probability, then using Bayes' theorem without data is just regurgitating your priors. And to me, that's not too much of a problem, of an issue, if you say so. So I think my problem is more when people do that thing. And for instance, your example, I think with the Sam Harris podcast and the 10% probability that we get wiped out by Gen AI, I think I listened to that podcast actually. Is that a recent one?
No, it was older. That was one of the conversations that got me interested in this subject in the first place.
Okay.
But I would say it's probably 4 or 5 years old by this point.
Okay. Yeah. So, yeah, because I've also seen a report like that about what the impact of Gen AI would be in 2027 or things like that. And they were doing a lot of things like that, where it's like, I don't know, you don't have any data to really back that up. So you're basically taking an assumption, and then just thinking about how we could get there, which is fine and again, to me, this is fine as a thought experiment. The problem is that sometimes you can convince yourself that actually this is going to happen and forget that you based that on an assumption, or in a less, let's say, in a less nice way of thinking about that, it would be more like malice, where I'm going to package that as something that is actually objective, and instead of saying it's just reflecting my degrees of belief about something that can happen, i.e. my priors, I'm going to say this is actually a probability of long-term event. So you basically, in the communication of the output, you swap the definition of probability that you had at the beginning. And I would say that is what really bothers me here. Because if you stop that, my priors are that, and so I think the probability of Gen AI wiping us out is 10%, and it's my belief. Okay, you didn't really apply Bayes' theorem. This is just the basis of Bayes' theorem, but okay, well, I mean, why not? So yeah, I'll stop here because I talked a lot already.
Yeah, no, totally. So I think we share intuition. I would maybe agree and sharpen what you said, which is that I have no problem whatsoever with someone saying, my opinion is that we will be wiped out next year with a 1 in 10 chance, or my gut feeling is that we will be wiped out, or what's your prior on the question of whether or not you're going to get the job next week? Well, my hunch is that it's going to be, it's pretty likely. That's all totally fine and great. The difficulty, or where the trap lies, I think, is that when one starts talking in terms of priors, and then when one starts talking in terms of actual probabilities, now you're comparing two things that have extremely different origins. So, for instance, we can come up with a probability that COVID-19 is going to, let's say, cause 10% of the population to be hospitalized, right? And so how can we come up with that? We can use Bayesian methods. So we could use like approximate Bayesian computation. We could get a giant simulator. It's actually a project I worked on, where you get a big simulator that literally has a computer program to say what's the probability that you're going to go to work and you're going to touch something. And so we're talking like 100,000 lines of C++ code with like deep assumptions based on the spread of disease and how the city works. And it's something that grad students have been working on for 15 years to be able to come up with these models. And that gives you a probability. And you say, okay, the probability is 1 in 10. I'm just going to keep using the same numbers. And then someone else says, well, my prior is 1 in 13. And now the fact that the first group is using Bayes' theorem and practicing Bayesian statistics, but they're still counting stuff. They're still coming up with frequencies, and the frequencies are Monte Carlo runs, right? And that number is then compared to someone's gut feeling. But people forget that they're switching between these two extremely different assumptions about what the nature of probability is. And so if you license yourself to use a subjective interpretation of probability, and then you kind of forget that, and then you compare it to counting asteroids or looking at the MCMC runs from a giant simulator. Now you're comparing someone's gut feelings to 30 years of research, right? And this is exactly what Toby Orr did in his book, and it's escaped even someone as wise as Sam Harris, because if I just tell you what the probability is, then you think, okay, got it. That's some objective thing that people have calculated. When in fact, no. Probabilities are not all made equal, and probabilities derive from models, derive from data. Like, even when we talk about a prior, like, you can absolutely do empirical priors where your priors are informed by data. So nothing is intrinsically data independent about priors, because there are techniques to inform your priors if you're taking a Bayesian statistical approach. And so my main rub against Bayesian epistemology is that I just don't think that is how knowledge is produced and how we actually make scientific progress. I think we make that through Karl Popper's philosophy, conjectures, and refutations, which I'm sure we'll go into at some point. So my biggest problem is that I just don't think that this accurately describes how knowledge is produced. But my more immediate problems and the more applied problems are that it allows people to compare numbers that have extremely different origins and then potentially make extremely bad decisions based on this. So one extremely salient example is Sam Bankman-Fried. So if you read the book that came out by Going Infinite, I forgot the author's name at the moment, same guy who did The Big Short, you can just read that Sam Bankman-Fried just viewed everybody and everything as just walking probability distributions. And now he's in jail. And he's in jail because he has he made certain decisions based on faulty epistemology that wouldn't have happened had he not been drunk off probabilities, shall we say.
Yeah. And so let's try and make that a bit concrete. So basically, let's go back to the part you like, the Bayesian statistics part. When a working statistician fits a model with priors and unlikelihood, what work is the Bayesian machinery doing that you think is legitimate and useful?
Yeah. So Bayesian statistics, for your audience will know this for sure, but Bayesian statistics is differentiated from, say, a frequentist statistics in the sense that it uses random variables as your parameters, right? And so that gives you a lot of freedom to incorporate in knowledge that doesn't really have an entry point via other means. So, for example, if we are trying to uh, get an estimate of the average height of people in Canada, say. Well, that's a really nice domain for Bayesian statistics because you can put a prior over what you think the height's going to be. You know, the height's not going to be 0. You know, the height's not going to be 100 feet. And so that's just a really nice way to incorporate in some just domain knowledge into your problem such that the answer you get is making use of this common sense information we have about the problem. And that's all fantastic. And in particular, it's fantastic because you can get a model, the Bayesian model, and then you can compare it to your data and you can be like, oh, my model is wrong. This was a bad model. I need to go back and I need to reassess. And so to the extent that Bayesian methods, when used in statistics, are falsifiable, and you can use data to figure out if your modeling assumptions were bogus or not bogus, I think it's fantastic. So that's just one example, but you can talk about how variational autoencoders work. You can talk about MCMC, and there's all sorts of real world problems for which this assumption that your random variables that your parameters are random variables makes a lot of sense, and it's been validated and it works in practice. I wouldn't say that it's better or worse than frequentist statistics. I would say it's just a different kind of statistics, and any statistician these days is going to be practicing both, and they're going to know about the kinds of problems for which, say, a bootstrap estimator or other frequentist estimators of uncertainty are appropriate, and other problem domains where Bayesian statistics are appropriate. So from the perspective of like the Bayesian frequentist debate as applied to like engineering problems, no dog in that fight. I think both have their pros and their cons. Where I have more of a dog in that fight is when it comes to epistemology, and when it comes to saying things like the way that Newton was able to come up with his theories was using Bayes' theorem in his head somehow. And so when it's used as a model of scientific discovery, that's where I think one can start running into difficulties, quite severe ones, in fact. Yeah.
Mm-hmm. Yeah, so let's talk about that. What's the central thing concretely on that Bayesian epistemology is a general framework for reasoning under uncertainty gets wrong, according to you?
If I may take a bit of a historical lens on that. So on our podcast, we talk about Karl Popper a lot. He's a philosopher that had a big impact on me. And he also was writing, basically he was born in 1902 and he died in 1994, meaning he was writing throughout the development of measure theory. He was writing when all of these probabilists were really working on probability theory. That was when like the Banach-Tarski paradox was discovered. That was when Kolmogorov started working. And so throughout the 20th century, there was a huge amount of development on probability theory. And a sizable percentage of these economists and philosophers, not so much the mathematicians, they were kind of just working on their measure theory, wanted to use this as a framework to explain where knowledge comes from. And that's essentially where Popper says, hold your horses here, fellas. I don't think it works that way. So maybe one way to enter this conversation is to think about Newton's theories when they were first, developed in the 1700s. When they were developed, they were basically seen as like, we have finally found true knowledge. This is pre-Einstein, so this is before we realized that Newton's theories were wrong. And Newton's theories just gave us this like insane amount of predictive power, an insane amount of engineering capabilities. It allowed us to figure out how to shoot cannonballs. It allowed us to explain how the moon stays up in its orbit, and it told us so much, not only about the things you can immediately see, but it told us stuff about stuff we can't see, stuff that's like in another galaxy. It explains how planets would orbit stars. And so this was the problem that a lot of philosophers are trying to figure out. So how is it possible that human beings were coming up with scribbles on their piece of paper in some place in Europe are able to discover general truths about the entire cosmos, truths that they haven't themselves seen or don't have immediate access to. So you can't touch a force. You can't see a force. You can see a bowling ball fall. You can hypothesize that it falls because of a force, but you can't actually see it, right? And so the traditional answer for how this comes about is via this process called induction. And so induction in the Popperian worldview is like a dirty word. Induction is something that we Popperians don't like very much. But what is induction? Induction, in this case, simply means knowledge is acquired via repetition. So the way that Newton was able to discover his laws was by repeatedly observing apples falling from trees, say. Now, Bayesian statistics is just Bayesian epistemology is just a form of induction. It's this. It was an attempt to fix what is called the problem of induction, and the problem of induction is just that. All these philosophers said that you gain knowledge by repeated observations, and yet it's logically impossible that seeing an apple fall a whole bunch of times can tell us a general truth about what's happening in the Andromeda galaxy. And so philosophers from like Francis Bacon all the way to Bertrand Russell were wrestling, and David Hume is the guy who named the problem of induction. They were wrestling with this apparent contradiction, and the contradiction is, on one hand, all the philosophers saying that we get knowledge because of repeated observations, and yet logically it's impossible to get any knowledge about something far away based on immediately what you see. So then Bayesian epistemology was an attempt to patch this. So it was an attempt to say, okay, sure, maybe we can't be absolutely certain that Newton's laws are true given the things we've seen, but maybe we can be probably certain, or maybe we can be less uncertain. And this is what a lot of work has been spent on, is trying to basically use probability theory to patch the problem of induction. Now, so your question was like, what's the big problem with this, and why don't I think that this works? Well, so for a number of reasons. So in the Bayesian framework, this is repeated observations. So you call them repeated. So you see a bunch of evidence, right? And now when I say evidence, I'm not meaning a row of a CSV, right? So a row of a CSV is totally legit. That's data. What the Bayesian epistemologists meant is you just see it. You just open your eyes and you just see evidence. But the question is, well, what evidence? So what counts as evidence only counts in light of the theory. So you have to have your theory first, and then based on your theory, you can figure out what counts as evidence. But it's a circularity, or it's an infinite regress. If you're going to say that your theory comes from evidence, then that just doesn't make any sense. So there's one major issue, which is that when Bayesian epistemologists try to explain where Newton's theories come from, they start with a prior over H, and then you have your likelihood, evidence given H, but you've already kicked the can down the road, because the question is, where does H come from? And so H can't come from evidence. It has to come from some other process. So that's one problem with it. I think the other major problem with Bayesian epistemology is that it encourages you to find evidence in support of your hypothesis. Every astrologer on the planet, every conspiracy theorist on the planet looks to find evidence in support of their theory. It's extremely easy to find evidence that supports your view that homeopathy is going to cure your cold. It's extremely easy to find further evidence that 9/11 was an inside job. If all you're looking for is evidence to support your preferred view, then you're going to find a lot of that quite easily. What Popper did, and we can punt on talking about Popper as long as possible, but he inevitably rears his head when this subject comes up. But Popper's whole point was that no, the scientific mind is not looking to find evidence that confirms the hypothesis. It's always trying to find evidence to disconfirm your preferred hypothesis. And so I think, to summarize, my main problems with Bayesian epistemology is that, one, logically it just doesn't make any sense. You can't explain where a hypothesis comes from by talking about evidence in support of it, because the evidence only works given the hypothesis. And two, it produces dogmatism. It produces this idea that you should only look for stuff that supports your view. And then three, which I haven't mentioned yet, but we can go into it, is that as soon as you start trying to patch the problem of induction with math on top of it, you're basically building an edifice on a logical impossibility, and then infinite numbers of paradoxes emerge. So one of the major paradoxes in Bayesian epistemology is something called Hempel's paradox, or the Raven paradox, which some of your listeners may be familiar with this, but it's this idea that if we're trying to find evidence in support of the theory that all ravens are black, all ravens are black. So that is equivalent to, if a thing is a raven, then it is black. And as soon as you have an if-then statement, you can take the contrapositive, which is, if a thing is not black, then it's not a raven. And then that would count logically, it would be equivalent to seeing a black raven. So Hempel's paradox, or the Raven paradox, is just the idea that any green shoe you look at, or any orange ball, or any San Pellegrino cup that's not black, would be in support of your hypothesis that all ravens are black. So how can you possibly claim to have knowledge and understanding about how ravens work by looking at green shoes? So Bayesian epistemology, because it is so fundamentally subjective, because it really encourages you to go inwards and think about your beliefs, and it doesn't encourage you to go outwards and experiment, and it doesn't encourage you to go outwards and actively find information that goes against your beliefs and actually try to disconfirm your beliefs. I think it causes people to run in circles. I think it causes people to become extremely dogmatic, as Sam Bankman-Fried, I think, is evidence of. And I think it logically just doesn't make any sense. And so those are the main reasons why I am not a big fan of Bayesian epistemology, but still am a huge fan of Bayesian statistics. And that line is something that I constantly have to walk in the other direction with our audience on the podcast, because some people who are extremely anti-Bayesian now will want to write off all of Bayesian stats too. And I have to be like, no, hold on. Bayesian statistics is great because you have data, because you can be falsified by your data and your models. But Bayesian epistemology is less good, shall we say. So yeah.
Right. So the main, one of the most potent points in your critique is that whatever the name actually of your framework of epistemology, whether that's Bayesian or anything else, it needs to be falsifiable, and it needs to have falsifiability as a first-class citizen in it. Otherwise, you can't really know when you're producing knowledge, or you're just producing more evidence for your prior beliefs. Is that correct?
With a few asterisks. So the first asterisk is that that's absolutely true for what we consider to be science. So a scientific hypothesis has to be falsifiable. But philosophy is not falsifiable. There's all sorts of ideas that aren't falsifiable, but yet are still extremely valuable. And so Popper's philosophy, he called it critical rationalism, or inverted, you can say it's all about rational criticism. So the generalization of falsifiability is criticism. And so Popper's epistemology takes criticism as a first-class citizen, not falsifiability. So falsifiability would be a kind of criticism. In particular, it's an empirical kind of criticism, where if you are so lucky as to come up with a theory that can, in fact, be tested, then your whole goal is to try to falsify that theory. But there's all sorts of theories for which they just don't have tests. The integral calculus. How can you falsify the integral calculus? Well, you can't run experiments to falsify it, but you can absolutely criticize it. You can absolutely discover things inside it that don't make any sense, such as what I mentioned earlier, the Banach-Tarski paradox. And so Popper's epistemology takes criticism as the fundamental unit, the most important thing. And then various types of criticism apply to various kinds of domains. So in the scientific domain, experimental tests are one of the most important kinds of criticism, but also peer review. Also, the peer review process, just explaining your idea to a friend on a podcast and having them be like, huh? What does that mean? That's a kind of criticism that's entirely valid, because the whole goal is to error correct all of the bugs in your thinking. It's not to demonstrate that what you believe to be true has high probability, for example. And so falsifiability is what people know Popper for most, because that's one of his most important contributions. But that contribution he made when he was 16, and that was kind of like one of the first things he did. But then what he went on to do was generalize that concept so that it applies not only to science, but to philosophy and metaphysics and art as well. Art criticism is just as valid, or stand-up comedy. So you can find domains for which they get immediate real-world feedback and criticism, and those are the domains that are the ones that are going to make much more progress, because they're the ones that have some sort of feedback mechanism that tells them when they're wrong. And so that's the most important thing. Experimental tests are a kind of that, but it's not the only form of that.
Okay. That's fascinating. So basically, critical, and I was going to ask you about Popper and critical rationalism. So that's great that you did this already. And basically, that philosophy includes falsifiability with experiments in science, but it's not reduced to that, in the sense that critical rationalism will be helpful for other domains like art, stand-up comedy, as you were saying, where you cannot falsify, but you can criticize rationally.
Exactly.
What I would like to understand better is, how does critical rationalism work concretely when you cannot make experiments? So that can have to do with stand-up comedy, for instance, which I'm a big fan of. It's one of my hobby. So definitely take that as an example, please. But also, still in science, you have cases where you cannot run experiments, but you can make inferences. Causal inference on quasi-experiments, for instance, is an example. How would that work here?
So inferences is a word that has a specific meaning for machine learning people. Basically, when you're not in training mode, you're in inference mode. But maybe for the people outside of ML, often inference just means like some secondary conclusion that is not immediately apparent, but yet can be inferred or guessed or deduced, or somehow you get from A, which is the immediately obvious thing, to some B, which is less obvious. So I'm going to take inference to mean that more general notion, if that's a fair way to understand your question. And so if your question is, how do we get from A to B? How do we start with some information like it's raining outside to an inference like I should bring my umbrella, right? what Popper says is essentially he doesn't care. And that's going to not be as vacuous as it initially sounds. So you could get from A to B because B logically follows from A. So it could be A is, I think that DNA is wound as a double helix. I'm going to think really hard and deduce that that would lead to an experiment where I shine a light on it in a particular way, and it would make a particular shadow pattern on the wall. So that would be like a deductive inference, and that works in some cases. It's not most cases. Sometimes you're lucky enough that you can logically deduce secondary information. Other times, you just need to make a wild, crazy guess. There is no mathematical or formulaic way to get from A to B. It's just a conjecture. You can take a lot of acid and go into a float tank for all Popper cares, come up with some idea. But what Popper did, and what his move here was that everyone at the time was trying to figure out like a reliable way to go from A to B always. And Popper said, I don't care. All I care about is once you have B, how can we see if B is correct or if it's not correct? So his whole framing is on error correction, and it's not on a specific method that will reliably produce truth, right? And so once you make that reframing, then all of a sudden a whole bunch of moves open up to you, which is, one of them is that however you get your idea, I don't really care, as long as you can present your idea in such a way that it's clear to the person you're speaking to what you're trying to say, so they can understand it, and then they can criticize it. So kind of the moves that are looked down upon by Popper would be to have an idea that is so vague such that the person who you're explaining it to can't understand what you're saying and then can't even criticize it. So if you reframe the way that we get from A to B as being less important than figuring out how to remove the errors from B, then you can start making a huge amount of progress in all sorts of different domains. So to go to stand-up comedy, for instance, you could use stand-up comedy as an experiment, and the experiment is quite simple. Are people going to laugh when I say this thing? If they don't laugh, the experiment has failed. If they do laugh, then experiment has not been proven to be always funny. It might not be funny in another context, but at least you've attempted to falsify your view or criticize your view of the humorous nature of your joke. The Bayesian epistemologists would instead think of it as, okay, given all the information in a person's head, how can you reliably produce funny jokes over and over and over and over and over again? Like, how can we come up with a process to produce that funny joke? And that's, I think, one of the central reframings that Popper's work provides the reader, which is that it doesn't matter. It doesn't matter how you get from A to B. Like, there obviously are differences between deductive logic and conjectural inferences, but at the end of the day, all that matters is if you can criticize, if you can critique, if you can falsify, if you can error correct, if you can remove the mistakes with the new piece of information. And so Popper sometimes is described as either a fallibilist, i.e. the idea that all people are always fallible, or a negativist, the idea that all that matters is the elimination of error, contrasted against the positivists who are positively trying to come up with a formula, a mechanism, an AI, a training procedure that will reliably produce new knowledge. And so that's the difference. Yeah.
Okay, super interesting. So yeah, for the stand-up example, that's interesting. The problem is that, so the main issue I would have with that is, I mean, the main question is not an issue. My main question is feasibility, in the sense that it's not that easy to run that experiment when you do stand-up. Like, if you're on stage and you're not a known comedian, you go to open mics. Open mics are a very weird sample of people who go there in the audience, and the audience is very variable. So someone who is very well known, like let's say Ricky Gervais, if he goes to an open mic to test material, it's somewhat random because usually they don't say Ricky Gervais is going to be there, but he knows his audience and he already knows what people who finds his joke funny are, who people who find his joke funny are. The problem if you're a completely anonymous stand-up comedian who just does random open mics is that you cannot really repeat the experiment because you don't have the same people in front of you, or at least the same audience with somewhat similar audience characteristics. So you kind of repeat the experiment, but not really. Like the only thing that doesn't change is the joke, but the audience changes, and it really depends on that. So yeah, here I'm a bit like, my question is, okay, like I see what Popper means on paper. I'm not sure how feasible it is in all cases. And a second question I have is, okay, so it's critical rationalism. I think we have covered the critical part, and I think the rational part is very important too. And so what makes a critic rational? Because I'm guessing this is extremely important to Popper's framework, knowing some of the rest of his production.
Mm-hmm. Second question is easier, and then let's do the first question after that.
Mm-hmm.
What makes a person rational is the willingness to listen to criticism. That's it. Criticism is not easy to receive. I don't like getting it. No one likes getting it. But the rational mind is the one who will earnestly listen to someone tearing their life's work apart and say thank you afterwards. And that's it. So rationality is in Popper's worldview, and I would say in my worldview too, in the sense that I'm extremely influenced by him, is simply the willingness to receive criticism lovingly and in a spirit of appreciation. And so someone, I think Popper's was able to distill his entire philosophy into one simple motto, which is, I may be wrong and you may be right, but together we'll get closer to truth. And that's it. And so it's all well and good to talk about. So now to move to your first example, which is that if Ricky Gervais goes to a show of his, he's getting a biased sample, right? That was, I think, partly what you're saying. And how can this be a good experiment if he has a biased sample? Because the people who are listening to him are already biased to like his work, and so it's not really a great experiment. I would say 100% agree with you. Not a great experiment from the standards of rigor that, say, a microbiologist would have to undergo in order to determine if their drug works for the whole population. Of course, for that kind of problem, you absolutely need much more rigor than a biased sample. But if you reframe Gervais and the stand-up comedian as not running a thorough, unbiased A/B test, as like Meta would have to do, or anyone doing drug discovery would have to do, but just getting some more criticism, then all of a sudden, the biased sample doesn't matter too much. What matters is that it's just yet another round of criticism. And so maybe to fill it out a little bit, so you were bringing up this idea that it's not very feasible in practice because the stand-up comedian can't randomly sample every person from every demographic in every geographic location. Absolutely, they can't. But what they can do is set up their life so that every conversation they have, they're doing a little bit of trial and error. They're trying out a new joke here and there, and they're saying, oh, okay, that one landed a little bit. Oh, didn't land. Okay, so I just tried to make my 4-year-old kid laugh. Didn't work. Tried at my wife. That didn't work either. Oh, but this one made both of them laugh. Okay, sweet. Now maybe I'm going to take this joke and I'm going to try it at a few like off-Broadway comedy sellers, like the Comedy Cellar. And this is, in fact, how these comedians do it. They are constantly workshopping their jokes, and then they'll go to a few small places where they're not really well known. And then over about a year of this, they'll whittle down 10 hours of material into like a tight 45 minutes. And that whole year is a whole Popperian year of subjecting themselves to criticism from wherever it comes. And so thinking about experiments as a kind of criticism rather than criticism as a kind of experiment, which I think is how you were thinking about it, is I think very important, because when it comes to criticism, doesn't really matter if your sample sizes are biased, as long as you have a lot of criticism. And just the more of it you get, the better your work will become. Of course, nothing I'm saying would apply to drug discovery, because there, one kind of criticism is like, you can't just test this drug on like your nephew and your wife, because you'll get people killed. And so one of the kinds of criticism there is that you absolutely need to be thinking about like unbiased samples and having large sample sizes and stuff, because the stakes are so much higher, right? So that was like one of the big aha moments for me, because I've always loved science. I've been like a science nerd from day one, and like I remember learning about like the scientific method and like, I don't know, grade 5 or grade 6, it's that little like flow chart thing where you have like a hypothesis and then you do a little experiment and then you analyze your results and then it comes up with a new hypothesis. That is like the same level of resolution as like the Bohr model of an atom, where atoms or like electrons are floating around like this. Obviously it doesn't actually work like a solar system. You have like a quantum cloud. And science doesn't actually work in this little circle. Science works by criticism first and foremost, where experimental testing is just one mode of criticism. But the reframing that I found so valuable was just this like, oh shit, I need to set up my whole life to be able to receive criticism from as many people as I can. And that means like not being a jerk, because if you're being a jerk, then people aren't going to want to talk to you. And if they're not going to talk to you, then you're not going to get criticism very well. Or setting up a podcast or in a Discord environment such that everyone feels comfortable like tearing each other's ideas apart in a constructive way, right? And so how you set up your life and how you tune these dials such that you don't have so much criticism that everything is destroyed and the community is broken and your life just sucks because it's not working very well, to the opposite, which is even worse, which is like a Trumpian figure where no one can criticize him because he's gotten rid of every possible person in his orbit who would ever be offer a critical ear. And so that's the kind of the reframing, which I think is extremely important.
Yeah, completely agree. This is really fascinating. Really love it, and I think I got much closer to what you want to mean. So a stand-up example was really, really helpful, because like this is literally what I do. Actually, what you described is that I go to open mics, but I also workshop jokes on friends. They just don't know it.
Exactly.
Yeah.
And then you're looking at their facial expressions, right? And you're like, oh, that one didn't land. That's criticism, right? Even if they're not intending it, it's just it's like another way is like feedback, just some sort of information signal from the world. And note how this is intrinsically antithetical to the Bayesian epistemologist, because they think that the most important thing is making sure your beliefs are well calibrated, right? Your priors are well calibrated. This is an intrinsically inward view of epistemology. It's not an outward view. It's not a let's collect feedback from the world. It's let me go away into my study for 16 hours and think really, really hard about all the evidence I've seen in the last 15 years and then write a little probability on a piece of paper and then publish a book based on that. It's not about feedback from the world. It's again, epistemology, not statistics.
Yeah, I have to say I don't care too much about Bayesian epistemology.
Totally fair.
Because my goal is usually not to calibrate my beliefs, but to update them and to see if I need to update them. And so basically having an evolving mental model. That's like basically what I care about on whatever thing I do. And to evolve that mental model, you have to test it and do small experiments as controlled as you can, as we were talking about, but sometimes you can't. And also jokes, for instance, are extremely weird objects because it not only depends on the receiver, it also depends on the person making the joke, what he looks like, how he says the joke, where he says it, at what time. It's like it's a weird object, but like you can make progress anyways. It's gonna take a bit more feedback loops than a controlled experiment. But yeah, so and I think it's actually very close to Bayesian statistics, what you're saying, because the whole idea is we start from somewhere. It's a bit like MCMC sampling, right? We start from somewhere in the posterior space, but as iterations go, we get feedback and we get much closer to what the posterior distribution actually is. So that's how I think about that and view it in my head in a very simplified way. But yeah, Popper is really a fascinating author. I got introduced to him mainly through falsification and basically the foundation of epistemology, right? Especially through, as you mentioned earlier, pseudoscience, and basically trying to understand how you can, let's say, handle people who come with these kind of claims. And because it's so intuitive, like the problem of pseudoscience is that they often have extremely good and intuitive thesis. And it's like, that's why it's so attractive to most of people. It's like, oh yes, right. Of course that would work like that. It makes sense. And so, yeah,
I was just gonna say, and note how much evidence they have for their hypothesis. When evidence from the pseudoscientist or from the Bayesian epistemologist,
I have a lot.
It's an infinite amount. You can always come up with more examples of why your theory is correct. And to the extent that Bayes' theorem encourages Bayesian philosophy, which then encourages Bayesian epistemology, which then encourages people to just act this way in practice. This is the exact antithesis of the critical mindset, where so I guess it's just an interesting example of how some dusty old equations written 400 years ago can turn into the practices and behaviors that I claim lead to pseudoscience and to conspiracy theories.
Yeah, I don't. So I'm gonna butcher the example, but the point stands. That's why I'm talking about it. But I don't remember if it's Popper or if it's maybe Carl Sagan, who took that example of, like, to show you that you cannot prove a negative, like taking the example of, you cannot prove to me that there doesn't exist a giant teapot orbiting, I think it was Neptune or whatever planet. So you seem to be knowing that example, so please take it away, because you're going to make it much more justice than I will.
Yeah. So that's Bertrand Russell's teapot, right? Famous example.
That's Russell,
and I believe he was bringing that up in relation to his atheism. I'm very much an atheist as well, and the arguments that he was arguing against were, well, prove to me, Bertrand, Birdie boy, that God doesn't exist. Prove that this thing isn't there. And he basically said, well, you can't prove a negative. You can't prove the non-existence of something. And so that's related to critical rationalism in a number of ways. One is taking it in its positive framing, is that many ideas, many of which are good and valid, are not falsifiable. You can't prove them one way or the other. In a more negative framing, it's this idea that if someone doesn't want to hear criticism, if someone puts forth challenges that are impossible to solve, then you can never puncture through the dogma. And so in that example, I think he kind of highlights two nice Popperian concepts, even though Bertrand Russell himself was inductivist, and so he was someone that Popper argued with a bunch on that regard. But yeah. Actually, and another thing with Bertrand Russell is interesting. So Russell himself, I think, is a beautiful example of the critical mindset because him and Alfred North Whitehead, I believe his name is, came up with this like 1,000-page tome that was trying to put all of mathematics on a firm foundation of set theory. And so they put hundreds and hundreds of hours into trying to prove that all mathematics can be derived from a small set of axioms. And then this annoying guy named Kurt Gödel showed that their entire life's work was impossible. And what they did was say, thank you. That's it. You've just answered my question. They didn't start attacking Kurt Gödel. Like, imagine if they were on Twitter these days. But it's a beautiful example of the fallible attitude and this idea that you should be grateful when someone is kind enough to spend time to think about your ideas and offer you criticism of them. And their jettisoning of 1,000 pages of work given a proof that showed they were wrong is, I think, a really nice example of that.
Yes, yeah, for sure. And actually, something that reminds me from what you were saying about the rationality of the criticism defined by Popper. If I understood correctly, that's only on the eyes of the criticized, right? Not the criticizee. So basically, it becomes rational just because I take it rationally if somebody criticizes me, like criticizes one of my joke, for instance, and not because the critique is not rational. Is that correct?
It is correct. Yeah, you as much as I would like to be able to control the dogmatism of other people, as much as I try, I can't do that, unfortunately.
Yeah.
All I can do is control the way that I act and I receive criticism. And sometimes when you're speaking with a fine gentleman like yourself, both participants are just naturally trying to get towards the truth, and all criticism is offered in that spirit. Other times, the interlocutor is not like that, and they just hate you. I was on the Doom Debates podcast, which, if any listeners want to get a good example of what Bayesian epistemology looks like these days in practice, I would listen to Doom Debates. I was a bit of a jerk on that podcast. I was in a bit of a bad mood, and there was 300 YouTube commenters who were all tearing into me. And it hurt. It definitely hurt because I thought I did well in that podcast, but my attitude was kind of just, I had a bit of a bad attitude. And so, yeah, it would be so nice if I could shout at each of these commenters and tell them to be more rational, but I'll take criticism where I can get it. And even if it was a bit harder to hear, it was still extremely valuable for me. And it was one of the episodes that I learned from the most because of how much that particular criticism hurt. But again, criticism in any form is valuable, and so I definitely adopted. I changed a lot of things based on that, but yeah, unfortunately, you can't control other people. You can just control yourself. And I think realizing that criticism is like the most valuable thing that you could possibly receive from anyone in any form, I think is such a powerful reframing, and it's been extremely important in my own life. Yeah.
Definitely, yeah. I mean, couldn't agree more. And so I'm obviously asking you that because of the like social media, basically, and the tendency of people to be extremely radicalized on there. And so it's like, but what do you do if somebody is just giving you a critique which is ad hominem? You know, like they have nothing interesting to tell you, and they just attack you instead of attacking the idea. Sure. So, and the scientist in me wants to find a framework to handle that and just have an answer to that. But then I think Popper's answer to it is actually much better and much more useful. And actually, I think here probably the Stoics had that answer before Popper. Like, I see a lot of resemblance with Stoic philosophy here, and like Epictetus, where it's like an insult just becomes an insult because you're interpreting it that way. But if you don't take what's meant as an insult, it is not an insult. And actually, it's going to be much better because it's going to make the insulter much, much more angry at you because they'll see they basically cannot cannot get at you. And also the idea in Stoic philosophy that, well, actually, the obstacle is the way. So the critique you got is actually always useful because it's a critique, but it's not binary. The usefulness of a critique is not binary. It's a spectrum, and maybe it's at 0 if it's just an ad hominem attack. Maybe it's at 1.5%, where it's like, okay, most of it is garbage. Oh, but here there is one part that's interesting. I could actually get better with that, whatever the source or the form of the criticism was. And I think that goes directly into 100%. Popper's philosophy, as you were saying.
Yeah, Stoicism and critical rationalism or fallibilism pair beautifully together. Absolutely.
Yeah.
The Stoicism is less about like where does knowledge come from, and more about just how do you live the good life? How do you do with less? How are you? If you were to lose your house tomorrow, are you going to be okay? And I think the kind of equanimity that Stoicism can teach allows you to receive criticism much better. My favorite line from one of the Stoic philosophers is something like Stoicism teach. I got this from a lecturer online whose name I'm blanking on at the moment. I can try to add the show notes. But at the end of the lecture, he said, the Stoics teach us that every man will die, but not every man will die whining. And I just love
perfect.
That. Yeah.
That's awesome.
And every man will be criticized, but not every man will be criticized and whine about it afterwards, right?
Yes.
And
I love it.
And so with regards to like ad hominems and just when people attack you, of course, nothing prevents the critical rationalist from criticizing the criticism. Ad infinitum. And like where does the phrase like critical thinking come from? Well, it's a derivative of Popper's work, right? But yeah, so sometimes the criticism you receive just is low quality and they're just attacking you as the person. So often that I will tend to ignore, or like I guess one danger of talking about critical rationalism, and a trap that I've arguably fallen into in this conversation, is like deifying criticism and pretending like it's this outer worldly thing that never hurts. But no, of course it's going to hurt. Like the deeper the criticism is, like sometimes it really hurts. And so, especially when you're in like an extremely critical debate with somebody, and emotions are high and tempers are overflowing, and this has happened to me many times on the podcast. Listeners of Increments will know what I'm referring to. But yeah, a little bit of stoicism added on top, and just a bit of a realization that everyone is human, and that like even if someone has given you a big paragraph online and 3/4 of it is ad hominems, but maybe like 1/4 of it is actually valid, then you, the person receiving it, can focus their conversation on the germ of truth, and get them to sharpen their own criticism of you, if you are able to control your emotions. And I say that as someone who is extremely not able to control my emotions sometimes, but it's a lifelong project. But yeah. And then so basically, in a nutshell, Popper's philosophy is criticism is at the foundation. Everything you think about the scientific method comes out of that. Peer review, posting your paper on Twitter. Like I remember I was much more scared to post a paper on Twitter than I was to submit it to peer review, because I knew that Twitter was going to give me way harsher criticism. And so like you figure out how to set up your work such that you get like the right amount of criticism at the right stages, because sometimes an idea is so early that like if I was to explain it to you, you would be like, I think it's not going to work at all. And so you kind of want to think about titrating in the criticism at the right stages. You want to think about like, okay, there's a wall of YouTube commenters that are all telling me I'm a terrible person, but there's like 4 or 5 people whose opinions I really do respect, and I'm going to ask them to see what's valid there. And so framing your entire life around how do I take advantage of the fact that the world is going to criticize me whether or not I like it, and so I may as well harness that energy in an effective way, is the game of figuring out how to do science. And that's one of his central insights, and why he calls his life's work critical rationalism.
Yeah, I would I would even argue not only do science the way, right, but
100%.
mostly life.
Exactly. Yeah, no, just if I can echo that, because I don't want to give the impression that this is just what us stodgy academic-y science people do. It's just as much what the roofer does when they're trying to figure out why your roof is leaking, just as much what your kid does when they're trying to learn to ride a bike and then they fall, and that's a little bit of error correction. They should have done it differently. And so there is no distinction in the Popperian worldview between the scientist, the human being, the artist, the comedian, the UFC fighter. It's all just learning from the world as best you can.
Yeah. Love it.
Mm-hmm.
Fascinating. And actually, so most of my work is trying to take the latest state-of-the-art science and trying to distill it to people who either don't have the time or the inclination to read the papers or talk to the researchers and just like doing that. And I think it's very important because papers are fine, but nobody reads them, only scientists, and they just read each other, but normal people don't. And so we need people to take the science and just push it out there, because otherwise most of the population is just going to stay with old beliefs, and that's not what you want. In the end, you want the science to be applied and not only written. And so that's why also I love a lot stand-up comedy. You've got a lot of very good stand-up comedians who actually kind of do, epistemology like that.
100%.
I think Ricky Gervais is actually a good one. Jimmy Carr, I think, is a good one. They often are very rational, so that's interesting because I think they have to be very analytical. And a very good show for that also that I often cite is The Big Bang Theory. And Sheldon in particular has some very good snippets, sometimes. And I think it's great. There are two which comes to mind for our conversation, which is one, that Penny makes a joke about Nebraska. She's from Nebraska, and I don't know, like another state that Nebraska looks down on. And she makes that joke in the apartment of Sheldon in Pasadena, California, and nobody laughs. And then she's like, oh, well, I guess that joke is only funny in Nebraska. And then Sheldon says, oh, you cannot say that. With the data at hand, you can only say that that joke is not funny here. Which is exactly what you were saying.
Exactly. There's no way to generalize beyond the local in a reliable, inductive
and I
way.
think that's awesome because everybody can understand that. And yet it's a very profound concept of scientific thinking. And I think this is a great distillation of scientific principle for everybody.
Very nice.
Which is extremely, extremely precious. And another one I really love that's also related to what we're saying, about with the teapot, and the burden of the proof is basically on the people saying that God exists, is so Sheldon's mother in the show is very religious, so she basically tells him at some point that to prove to him that God doesn't exist. And then Sheldon is like, well, imagine that I told you that I believe there is a giant invisible man in this room that influences your behavior. The burden of proof wouldn't be on you to disprove me. It'd be on me to prove you that I'm actually right. And it's another example of a great way to distill what we've been talking about.
Exactly. Totally.
I love it. Yeah. So actually, I still had a lot of questions for you, but it's getting late. So I don't wanna take too much of your time. And since I'm gonna come on your show at some point, actually I can keep some of those questions, and if you want, I can ask them to you, and it's just gonna spark some interesting conversation between us. What do you say?
Yeah, sounds great. Yeah, I'm in no rush. So yeah.
Awesome. So let's do that. I'll keep these questions on my computer, and then when I come on your show, I can actually ask them to you, and then we'll just talk about that. I have some good one about a bit more concrete, one about a paper by Andrew Gellman. So just interesting stuff. And also, yeah, and two other questions that actually I think you're gonna like about falsifying your beliefs. So, but that's just a teaser for you. But so before you go,
next time on,
yes,
yeah,
exactly. So before you go though, I do want to talk a bit about your show, Increments Podcast with Ben Chug. You've been running that for a while now, and so I can definitely say congratulations, because it's not an easy job. What's the elevator pitch? Who's the audience? And what made you want to start a philosophy of science podcast in the first place?
Yeah, what's the elevator pitch? I don't know what the elevator pitch is. So I'm still trying to figure that out. Typically, I just say it's applied philosophy, or it's a philosophy and science and history and everything in between. The elevator pitch is that, so I mentioned a little bit about Popper, how he was writing in the 20th century. And if we just think a little bit about all of the things that happened in the 20th century. So we have Marxism, and we have Freudianism, we have Einstein, we have Turing, we have Kolmogorov, we have Dawkins and the selfish gene, and we have Turing, if I already mentioned him. So to study Popper is to study everything, because he was in the weeds with all of these subjects. And so I like to think of epistemology as like the master subject, the center of the Venn diagram. And so on the podcast, we are kind of just exploring outwards from the center. So we have an ongoing series where we're going through chapter by chapter of conjectures and refutations. In between that, we spend a lot of time talking about AI, and in particular, reasons why artificial general intelligence is not going to happen in our lifetimes. Controversial claim, see next episode. We spend a lot of time talking about effective altruism in a bit of a negative way. Effective altruism is a strong hotbed for Bayesian epistemology and for a newer philosophy called long-termism, which I'm quite critical of, and I can maybe share a few blog posts to put in the show notes where I criticized one of William McCaskill's papers, and then he ended up taking it down and removing all the quotes that I had quoted from him. We talk about open societies, so we haven't talked at all about Popper's political philosophy, but that's a huge current. And then we just have random episodes discussing kind of current cultural trends. So Jonathan Haidt's work, this idea that if you give screens to your kids, you're going to rot their brains. My daughter has an iPad and she's loving it, and it's been the best thing ever. So extremely pro screen time, for example. We had an episode about recycling and why recycling doesn't actually work very well. So we try to go from the extreme niche philosophy discussions about what truth is, how probability works, what certainty means, how does logic work, how do you go from logic to the real world, like what's the connection between logic and the real world, all the way down to the super mundane, like does recycling work? What's this notion of the patriarchy? Is the patriarchy a valid concept? And everything in between. And both Ben and I should just shout out Ben. So Ben's finishing his PhD at CMU. He's like statistician extraordinaire. He's doing fundamental work on E-values, which you should totally have Ben on, because I think your audience, who's primed for technical discussions, would love to hear some of the stuff that he's working on. Is Mike Jordan, for example, is on his committee, so it's deeply into the ML community there. And him and I have extremely short attention spans, and so we get bored of subjects pretty quickly, and so we like to keep moving on to new things, and the world right now is not boring, shall we say. So there's plenty of stuff to talk about, and those are the kinds of subjects we touch on. Why did I start the podcast? Why did we start the podcast? It was started during COVID, when all of a sudden I couldn't do my favorite thing in the world, which is going to the bar and arguing with all my friends about politics. And so when that stopped, I was like, well, this is not acceptable. And so Ben and I started our little conversations, almost 5 years ago now. And we just had our 100th episode a couple weeks ago, and that was a nice accomplishment. And yeah, we're looking forward to the next 100. I have no idea what the future is going to hold, but just chasing our interests as they come along.
Well done, well done. Yeah, this is a very interesting show, and I didn't know about it before Andreas put us in touch. But yeah, have to say, definitely you have a new listener here, and this is exactly the
amazing.
kind of nerdy, serious, and entertaining content that I love, that I try to do here, and that I hope the world had more of. So definitely thanks a lot for doing that, and I'm sure a lot of my listeners are gonna enjoy it. So, folks, it's gonna be in the show notes. Make sure to give a listen to Vaden's and sorry, and Ben's podcast. That's the French guy in me, wanted to get out because I can never let him out when I'm in the US.
Yeah.
So sometimes I have to talk like that, like a real French. And yeah, so look at that. I'm going to be on the show. So it's the mark of a show that's not really high quality with guest screening, but still other people who've been on Vaden's show are really, I vouch for them. So
yeah.
Well,
thank you so much.
No, you bet. You're doing a lot of good work, so I'm really happy to help you guys on that. And well, let's call it a show, Vaden. I'll come on your show and ask you my other questions. Before we go, though, I have 2 questions to ask you at the end of the show. Before you go, I ask that to all my guests. So that I have a distribution of answers, right? So first question, what's your favorite thing about Bayesian epistemology? I'm kidding.
I got to answer the question. It encourages people to learn more about math. I think math is awesome. And if that's a good entry point in for some people, then I think it's a great way to start learning about math and equations.
Yeah. Okay. Love it. And yeah, that's a good answer. But that was a joke. The actual first question is, if you had unlimited time and resources, which problem would you try to solve?
Ooh, nice question. If I had unlimited time and resources, I think the problem of education is really interesting. I think that figuring out how to create environments where people are free to explore their own interests and explore their curiosity, while also being realistic about the fact that there's a short supply of qualified teachers and that parents need a place to put their kids while they go to work, is an extremely interesting question, and one that I think if we were to make progress on that, it would just unlock an infinite amount of unbounded potential. But I think there's a lot of wasted opportunities that come from people not having the freedom to just explore their own interests and curiosity as much as I think that everyone should be able to. So maybe that.
Yeah. Very, very on point answer with your brain. So I am not surprised. And second question, I think I know the answer to that one, but we'll see. If you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
Okay, so Popper's the easy answer, but I'm not going to say Popper.
Okay,
Richard Feynman.
Just to make me wrong.
Yeah, Richard Feynman, because I also play music on the side, and I heard he's an insanely good bongo player, or was an insanely good bongo player. And I'm attracted to the kind of mind that loves science, but also loves people and human interaction and humor and joy and life and drinking and just having a good time. And I find that intersection is in short supply. And so Richard Feynman would be definitely someone I'd love to go for dinner with.
Okay. Yeah. Love it. And yeah, the dinner table is getting crowded. We've got a few guests already. So we'll need to find a bigger restaurant, but let's make it happen nonetheless.
Yeah, it sounds great. Yeah, awesome.
Well, Vaden, thank you so much for coming on the show. There will be a few links folks in the show notes for that episode, also a few related episodes. Feel free to check them out. I think they're going to be very interesting. Hope you enjoyed that episode. That was somewhat of a change of pace from the classic technical episodes, which I like to do from time to time, and I hope you did too. And on that note, Vaden, well, I'll see you soon, but mainly thank you so much for taking the time and being on this show.
Thank you for everything. This was a fantastic conversation and had a blast, and looking forward to part 2.
Well, I'm happy to hear that.
Yeah, excellent.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and follow the show on your favorite podcatcher, and visit learnbaystats.com for more resources about today's topics, as well as access to more episodes to help you reach true Bayesian state of mind. That's learnbaystats.com. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Loss and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbaystats. Thank you so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.